So the answer in this question, right, which one is correct, will be your C, because high-speed electron is beta, high-speed helium is alpha, and high-frequency photon is gamma. For this question, what we're going to do is, you're going to work backwards. So in order to get your, let's say, lawrencium, so lawrencium actually splits to be mendelevium and alpha. So what is lawrencium? So lawrencium will be equal to this plus this. So your alpha is actually 42, don't forget. So if we add up together, this to lawrencium will be 259 and 103. But then your lawrencium plus alpha becomes dubnium. So you add up together, give you dubnium. So you get plus another 42. So you get 263 and 105. Okay, and then borium is actually splitting to become dubnium and alpha. So we add another 42 to become your borium. So you get 267 107. So therefore, what is your number of neutrons? You're going to subtract, you will get 160. Answer is C. So if you read this question, what they basically said is you are having a radioactive source here, and then it will pass through aluminium, and then you're trying to detect it. And the count rate, which represents how many alpha, beta, or gamma per second that you actually can detect, is here. So as what are they plotting? The count rate versus the thickness of the aluminium. How thick how thick is your aluminium plate So firstly, they ask you, suggest why it's not possible to detect the emission of alpha here. That means you probably can detect beta and gamma, but you cannot detect alpha. So the answer would be, of course, if you notice there are 6 centimeters of air here, and the alpha won't be able to penetrate that as well. So even if you have no aluminium, you will definitely not be able to penetrate. But if you have aluminium burst, definitely 100% won't be able to penetrate. Alright, so you can say the alpha particles will not be able to penetrate. The alpha particles will not be able to penetrate the space between, the source and the detector. The space between the source and the detector. Next one, state the evidence provided from this figure 9.2, which is this, for the emission of beta. So how do I know there's beta here? Do you realize that for thicknesses up to 2 millimeters, the count rate actually drops very quickly? So it means from 0 to 2 mm, the count rate drops very quickly. So that shows that beta is being stopped, because remember, beta can be stopped by few millimeters of aluminium. So that's the evidence that's beta. So you can say there is a rapid drop in count rate. There is a rapid drop in count rate for thicknesses. There's a rapid drop in count rate for thicknesses up to 2 millimeters. There's a rapid drop in count rate for thicknesses up to 2 millimeters. So how do I know there's gamma? Is very simple. It's because after 2 millimeters, which is ask you how do you know it's gamma radiation. After 2 millimeters, it seemingly does not decrease much anymore. Still maintains about 1000 your count rate. That means even if I increase the thickness up to 6 mm, still not much difference. That means it must be gamma, because gamma can easily penetrate through aluminium. Okay, so you can say this. There's a very slow drop in count rate. There's a very slow drop in count rate for thicknesses above 2 millimeters. For thicknesses above 2 millimeters. So for this question, if they want to find the equation that represents the decay, so it emits beta, so you can write it down first. 90, 38 strontium. Now if it emits beta, it will be 0, -1e, but you must have conservation of nucleon number, so this remains at 90. So this has to be 39, right? So you add up together, you will get 38. So the answer is B lah. Okay, very good. So like some people will ask me what's the difference between A and B lah. Alright, so what will happen is, after you undergo beta decay, it will change into a different element. Why? Because your proton number changed already. So you cannot still remain strontium. So it must be a different element. Okay, so for this question, if you want to have beta decay followed by alpha, so for beta, the neutron number remain the same, but your proton number plus 1. Then for alpha decay, your neutron number drop by 4 and your proton number drop by 2. So your answer is C. So for this question, if you want to emit a beta particle, so what will happen is the neutron number remain the same, but proton number will plus 1, right? So the answer is D. So for this question, remember the particle, the radiation that has no charge and mass is actually gamma. So X has to be gamma, so it's either B or C. But if you look at the charge, if this is a charged electron, so this will be beta. So Y will be beta and Z will be your alpha. Alright, so these will be the typical speeds that we have talked about. Okay, so for this question, 1 alpha means what will happen? So if it's alpha decay, your proton number drop by 2, neutron number drop by 4. Another alpha, so drop by another 4, drop by another 2. Then beta, this one maintains and plus 1. So answer is C. Okay, well done. So how to get the greatest momentum? Now remember how we got the speed from the previous question. If you forgot, right, I quickly just go through. For speed, half mv squared equals to qv. So the speed will be 2 qv over m square root. So that's how you get the speed. So when they ask for momentum, which is mv, so we take the v from here and we substitute here. So you get m times square root 2 qv over m. Now in maths, right, if you take the m and you want to bring into the square root, it becomes a square. So therefore what you will get is square root 2 qv over m. Bring the m inside, it becomes m squared. So the m can cancel, so that's how you get square root 2 qvm. So in order to have the greatest momentum, since all of them have been accelerated through the same PD and 2 is a constant, so the greatest momentum P will be the one with the greatest Q, the charge times mass ratio. So how to get the charge and the mass? Charge take from a proton number, mass take from neutron number. So for alpha, proton number is 2, neutron number is 4, so 2 times 4. Electron is negative 1 times 0. Because the proton number is negative 1, mass is 0, neutron is 0, 1, proton is 1, 1. So if you look at these 4, the one with the biggest is your alpha. So the answer is A. So now when they say gamma radiation, beta radiation, alpha radiation, so which one is the one in part B? We're doing part B now. So what is not affected by electromagnetic fields is your gamma radiation, because gamma is just a wave, so and it is uncharged, therefore it will not be affected by electromagnetic fields. And which one will produce the greatest ionization? Alpha. Okay, very good. And which one does not directly result in a change in proton number? That means after the decay, it doesn't affect the proton number? Gamma. And which one has energies, a range of energies rather than discrete values? Now this one is a little bit different. Yeah, in the next video, when we talk about the fundamental particles, we're going to talk about how beta and beta plus decay occurs. Now, when beta decay occurs, it comes out with electron antineutrino. So the electron antineutrino will carry some of the energy, and this electron antineutrino has different values of energy. So therefore, your electrons will also have different values of energy. So what it means is your electron doesn't come up with a specific value, because discrete values mean specific values. It will come up with any energy is unpredictable, so because some of the energy is being carried by the antineutrino. So this is something a bit extra, but you need to know this. Alpha is not. Alpha, when it comes out, right, it has a specific energy. Same thing goes with gamma, specific wavelength. But electrons come out as beta, right? They come out with any energy, so answer is beta. So which one are the same type of radiation? Now if you look at L, M and N, your L has the lowest penetration, so I would say this is alpha, then this is beta, then this is gamma. Then we look at diagram 2, the one that passes straight through is gamma, the one that's deflected little bit is alpha, the one that deflects the most is beta. Similarly, in the magnetic field, not deflected is gamma, okay, the one that deflected a little bit is alpha, the one that deflects the most is beta. So from there, we can see that which one is the same particle, which is M, P, and Z, which is beta. Okay, so answer is C. So for this question, which one will be the maximum range of alpha? Remember, alpha is few centimeters of air. So few centimeters air is within this range. Alright, between 0.5 to 20 centimeters, so it's within this range. Answer is boy. So for this question, first it starts with beta decay, then only alpha, okay? So when you decay by beta, remember what happens is the nucleon number remains the same, because nucleon number is this side, so it remains the same. But the proton number will +1. So in other words, you must move horizontally to the right, because then the proton number will +1. So this is definitely wrong. This is definitely wrong. And this is definitely wrong. So you need to get left with 1. So we just want to confirm. After that, followed by alpha. Then your proton number will decrease by 2, which is decreasing by 2. And your nucleon number will decrease by 4. Alright, so the answer is B. Now, to convert 238 uranium to 234 Pa, right? Okay, how do we do it? So 238 92 becomes 234 91. So you notice that the proton number actually decreased by 1, and the nucleon number decreased by 4. So the thing that the moment I see nucleon number decreased by 4, I know there's an alpha. But then that would mean that your nucleon number should be actually you'll be correct, but your proton number is excess by 1, right? So that means there's another electron here. So now can you see it balances? So that means it produces an alpha and a beta. So the answer is A. So to fill up the values here, all we have to remember that charge of alpha is either 2e, because it's actually 2 protons, which has the same charge as the electron. Proton has the same charge as electron. So that's 2e, positive 2e, or you change it to coulombs. For electron, which is beta, we can put negative e or negative 1.6 times 10⁻19 coulomb. Now mass of beta, you use the mass of electron from the data booklet. Now alpha particle speed, you must know, is 0.1 c, and gamma is c. Now the last part here, explain the process by which alpha particles lose energy when they pass through air. So what happens here? So we can therefore say this, when alpha particles pass through air, it will collide. When alpha particles pass through air, it will collide with the air molecules. It will collide with the air molecules, causing the electrons to be knocked out. Causing electrons to be knocked out. Okay?